A magnetic field is the region in space in which a magnetic object will feel a force. Interacting magnetic fields is the reason why similar poles will repel each other and opposite poles will attract each other. And in a previous video, we also saw that a magnetic field is produced around any wire carrying a current. So if I put a current carrying wire near to a permanent magnet, those magnetic fields would interact and a force would be felt in some way. Figuring out the direction of this force based on the shape of the two magnetic fields can get a bit messy and get a bit complicated, but fortunately some dude named Fleming came up with a clever way of figuring out the direction of the force provided you know the direction of the current and the field under certain circumstances. And you can do this all using the first 3 digits of your left hand. This is called Fleming's left hand rule. Okay. So let's figure out how to hold our hand. We've just got to get these 3 fingers all at 90 degrees to each other, basically. So we're going to do it by, first of all, pointing our first finger forward, so like that. Then I'm going to point my second finger out to the side. So these 2 fingers are now at 90 degrees to each other. And then I'm going to put my thumb up. So now these 2 digits, I should say, I guess, are at 90 degrees to each other. These 2 are at 90 degrees to each other. And these 2 are at 90 degrees to each other. They're all perpendicular. So now we just have to line our hand up correctly. You're going to point your first finger in the direction of the magnetic field. You're going to point your second finger in the direction of the current. And your thumb is going to go in the direction of the force that wire will feel. Okay, so let's have a look at a few examples. So in this example here, the magnetic field is going that way, so to the right. The current is going down, so that means the force that the wire feels is going to be that way, out towards you. Okay, let's have a look at another scenario. Okay, in this example, the magnetic field is going up. We always want to go from north to south. The current in this case is actually coming out of the screen towards you. So my second finger is going to be in that direction, and that means that my thumb is showing me that the force is going to make the wire go to the left this time. We can even calculate the size of the force, provided that the field and the current are at 90 degrees to each other. All of the stuff I've said in this video only works if the magnetic field and the current are at right angles, but don't worry, that is the most common scenario that you'll come across. But we can actually calculate the size of the force as well. It's just going to be the magnetic flux density, which is basically a measure of how strong the magnetic field is. It's just a number. The magnetic flux density multiplied by the current multiplied by the length of the wire that's in the magnetic field. So there you go. That's Fleming's left-hand rule. I always like to think of it as the physics gang sign. Yeah.